Okay, so this is page 128, question number 43, and it's a mass spectrum question. And so it says the mass spectrum of bromine, Br2, consists of three peaks with the following characteristics. And then so they give us a table and they tell us there are three peaks. We can tell there are three peaks because there are three different mass values and three relative sizes. And think of relative size like percent, right? Like if this relative size is 0.50, that means it'd be 50% abundant. This one would be 24.6% abundant. This one would be 25.3% abundant. So what we want to do is interpret this data. Now, before we interpret it, I want to point out something that is unique about these types of molecules. So that's a diatomic molecule right there. All right, we know it's diatomic because there are two atoms of the same element joined together. And so if I were to do a mass spectrum of that, it has a really unique characteristic. For example, let's say I had X2, a diatomic molecule. X isn't a real atom. And let's say there were two isotopes of it. Atomic or mass number 14 was one isotope, mass number 16 was another. Well, this is going to produce three peaks. The reason why is it would produce a peak at 28, which would be 214 isotopes together. It would produce a peak at a mass number of 30, where 14 and 16 have joined together to make X2. And then the last peak would be a mass of 32, where two 16s would come together. And these are the only three combinations that are possible, so you would see three peaks for it. In this problem, exact same thing happens with Br2. You've got three peaks, which, like I just showed you, is characteristic of two isotopes, right? Two isotopes can combine in three different ways. So if I'm interpreting this data, I would say that bromine has two stable isotopes, which would produce three peaks on a mass spectrum. And again, the most abundant peak is this one. So whatever isotopes there were that combine and make a mass of 159.84 would be the most common isotope of bromine.